Alright, so next thing we're going to talk about are rational inequalities. Rational inequalities are inequalities that involve rational expressions, and we know rational means fractions. So here's the rational inequality that we're going to start with. If you need to pause the video and write it down in your notes, then go ahead and do that now. Now when we were back in section 1.1, I guess it was, and we were solving equations, and if this were an equal sign instead of greater than or equal to, the first thing we would want to do would be to clear those fractions by multiplying both sides by the denominator. Now while we treated the quadratic inequalities the same way as quadratic equations, we cannot do that here, because if I multiply both sides of this inequality by x minus 3, the next question I have to ask myself is, did I just multiply by a positive number? Or did I multiply by a negative number? And depending on what x is, the answer would be yes or no. So because we don't know whether this is positive or negative, we definitely don't know what to do with that inequality symbol, which means this isn't the approach that we're going to get to take. We have to leave the fractions in there, unfortunately. What we're stuck doing instead is very similar to what we did with the quadratics, where the first step is to get a 0 on one side. The next thing then is that we're going to get to find a common denominator between the two fractions, which, since 4 is just 4 over 1, my common denominator is going to be x minus 3. And 6 gets to stay a 6. That negative 4 gets multiplied by x minus 3. Over here. Now when we do that, if we distribute the negative 4 to both pieces, I'll sneak that in another color here, and if we add the tops together, adding across the tops, it looks like we have a negative 4x plus 18 on top of that fraction, and we have x minus 3 still on the bottom. Now if I have a fraction and I want to figure out when that fraction is equal to 0, like we did with the quadratic, we said I need to set up and find some of those key values so I can figure out where I can check, or what numbers I can check, so I can figure out where the solution set lies. Knowing that a fraction is equal to 0 is enough to say, well, I know that means the top has to be equal to 0. And I didn't leave myself a lot of room here, so we'll just go straight to the punchline and say x is equal to 9/2 is what solves this equation. But also when I have a fraction, I have to worry about the domain of that expression, which means I have to worry about the possibility that it will be undefined at one or more values of x. So I also get my key values from any place that makes the denominator equal to 0. So the top being equal to 0 is what makes the fraction equal to 0, this possibility here. What makes the bottom equal to 0 are the numbers that we have to avoid. And so now I have my number line broken into 3 pieces. It's not always going to be broken into 3 pieces. Occasionally you'll get one that only has 2 with a single key value. Sometimes you'll have 3 or 4 or 5 key values, which breaks it into 4 or 5 or 6 intervals. But just as we did with our quadratics, we're going to pick a number here. I like 0. The number between 3 and 4.5, that probably is going to be nicest to work with, is 4. Bigger than 4.5, I'm going to pick 5 for x. And what we do is we take those numbers back here to our original inequality, and we find out whether or not they work. We keep doing that in blue. So if I plug in 0 for x, it says negative 2 is greater than or equal to 4. And that's not true, which means my solution set is not down here. If I plug in 4 for x, it says 6 over 1 is greater than or equal to 4, and that's a true statement. So that tells me I am between 3 and 9/2. My solution set is at least in that interval. If I plug in 5 for x, it says 6 over 2 is greater than or equal to 4, or 3 is greater than or equal to 4, which is not true, which means I'm not going to be up here. The next thing I want to do is figure out what marks to put at the 3 and at the 4.5. I want you to pause the video for a minute and think about what you would put there. Now, most students say, well, I notice this says greater than or equal to 4, so I'm going to stick square brackets at both ends here. Now, that is only partially right. This equal to symbol does say, it does mean, that we are allowed to be equal to 0 or equal to 4. And the values that made this equal to 0 are the ones that satisfied that equation right there, which means x equals 9/2 is included in our solution set. I do need a square bracket there. But remember where the 3 came from. The 3 was the value that made that fraction undefined, that makes this fraction undefined, which means regardless of the symbol that we're given, whether or not that equal to bar is there, I can't ever use the number 3 because it makes me divide by 0. 3 is not in the domain, so even if I was down here, even if I was up here with my solution set, I have to stay away from 3 because it makes me divide by 0. So the solution set for this inequality are just the values between 3 and 9/2, not including 3, but including 9/2. Let's do one more, and then I'll try to be done because I want to keep this sort of short for you. If you want to give this one a try by yourself first, pause the video and then come back and turn it back on. I'll show you how it works. If not, you can just keep watching. First thing we want to do is get a 0 on one side. Next, we're going to find a common denominator, which is going to be x plus 2. Now the 1 minus x doesn't change, but this 1 here gets multiplied by x plus 2. When we combine our like terms this time, if I have 1 minus x plus 2, those x's go away, and 1 plus 2 leaves us with just a plain old 3 on top. Now, if I have a fraction, and I want to figure out where it's equal to 0, I focus on the top. And I want to know, when is that ever equal to 0? Well, 3 is just 3, just a plain old number. 3 is never equal to 0, so I'm not going to have any values, any key values coming from the numerator of that fraction. If we worry about when the denominator is 0, then the denominator is 0 at x equals -2. And that's the only place. So all I have to do is check on either side of that -2 and see where my solution set lies. So if x equals -3, up here 1 minus -3 is 4. -3 plus 2 is -1. And this says -4 is less than -1, which is true. So I know I'm down here. If I check to the right of -2, I'm going to pick 0. And it says 1 minus 0 on top over 0 plus 2 on the bottom. It says 1/2 is less than -1, which is not true. Now, the symbol being just strictly less than there means I can't be equal to 0, but there are no numbers that made me equal to 0 anyway. And I know that I have to avoid -2 even if this said or equal to, because -2 is what makes me divide by 0, and that's not part of my domain, regardless of the inequality symbol above. So using interval notation to write the solution set, we know the solution set goes from -∞ to -2. Now, I'm going to have a very short, I promise that one's extremely short, video that just has your exercise sets on it. And so look at that very last video, and then you should be done with me from chapter 1.